Okay, so these are a couple ones from the homework that I thought were a little bit harder. I think 6 is okay, but again, there's a copy of this on Canvas if you want to have the actual hard copy. I really want to do 7 and 5 because those are definitely a lot harder. So I'm going to start with number 7 right here in this slide. I'm sorry, in this video. Okay, so when I print out number 7 from 12.3 homework, this is what it looks like. So we have some fractions here. So I kind of wrote some notes here. So 3 cubed gives me 27, and 4 cubed gives me 64. I kind of put that up here. So 20 over 64 is the same thing as 3/4 cubed, because 3 cubed gives me 27, 4 cubed gives me 64. Or if I want the same thing as this, I'm going to flip it, and I'm going to put the negative exponent. Okay? So just kind of grasp that. You can pause this if you need to. So this part I keep the same. This part, instead of what I have right here, I'm replacing it with this. So these have exactly the same base. Okay, that's the hardest part, just identifying that part. Okay, once I have that, now they have the same base. I set the exponents equal to each other, and I get x is equal to -3. Okay, so there's that one. And now I would do number 5 too. Number 5 I think is pretty difficult as well, so I thought I would go over that one. Okay, so first of all, I'm going to look at 64 and 16. Both of these are 4 raised up to a power. You could actually do 2 raised up to a power, but I chose 4 because I thought the bigger number might be easier. But again, you could do 2 raised up to the 4th power and so forth if you want to do it that way. Okay, so 16 is 4 squared, and 64 is 4 cubed. So what I did was instead of 16 here, I put 4 squared. Instead of 64, I put 4 cubed right here. Okay, now I rewrote it. So I have 2 times this, and I put parentheses around it, so I remember to multiply all of it, and 3 times all of this. Okay, so now I'm going to set these exponents equal to each other. So this is right here, and this is right here. Now I have a linear equation, so I'm going to go ahead and solve it. I apply the distributive property here, and the same thing over here. I get 3x plus 6. Okay, I subtracted 3x from both sides. So over here I got 3x, and I just have the 6 over here. And then I added 12 to each side. Add 12 here, I get 0, and I add 12 here, and I get 18. And then if I divide both sides by 3, I get 6 for that answer.